This lesson is an intro to using functions in Excel, and it starts on page 140 in your notes. Up to this point, we performed calculations in Excel, like these, by writing formulas, and we'll always have to do that. But Excel has many built-in formulas, or algorithms, or functions, and we can make use of those. You'll want to open the Excel file called Worksheets, and it's on Blackboard, and then we'll be working on the Functions tab. So what is a function? A function is a piece of code that performs some procedure or routine or function and returns a value. And functions have a certain syntax or grammar. They start with an equal sign, followed by the function's name, and then in parentheses they have an argument. And the argument is what is being tested or worked on by the function, and then a value is returned. Now, almost all functions have some kind of argument. There are a few that don't require it. For example, the function pi, if I type in equals pi and then hit tab and then close the parenthesis, tells me the value of pi. Here's another one, equals now. What would that be? Well, that's the date and time. Or perhaps one like equals today. Gives me today's date. But in most cases, we'll be supplying an argument to the function to work on. So what are the functions that are available in Excel, and where are they? So on the Formulas tab, in the function library, there are a variety of functions listed according to category. These are financial functions, some logical functions, which we will look at briefly, text functions, they carry out operations on words, date and time, lookup and reference functions, math and trig functions, which we use a lot of, and there's more functions. I've read that there's over 300 functions in Excel. Functions are also listed under this Insert Function tool. So here we have categories of functions as we saw above. And if you know the name of the function you're looking for, you can simply type it in and press go. Or if you know the name of the function, you could type in the first letter. Let's say I'm looking for some standard deviation function. Type in the letter S and then scroll down. Notice I'm in the All Categories group. However, probably the quickest way, and when you're not really exactly sure what you need, the easiest way might be simply to start typing on one of the cells. So let's say I want to find a function related to standard deviation. I'll type in equals, and I'll start typing ST. So here's standard deviation of the population, STDEV.P, standard deviation of a sample. Here's STEYX, the standard deviation of a regression, and more. So there's another way we could find a function. On page 142 is a list of different kinds of arguments that functions use. For example, an argument can be a literal value. The square root of 25 is 5, and 25 is a literal value. The length of the word cat is a literal value. Arguments can be cell references, like the cell A1, or the cells A1 to A5. An argument can be a whole column of values. For example, this function calculates the sum of all the values in column B. Arguments can be expressions, such as A1 plus A2 plus D7, and this function will give the sum of those values. Arguments can be arrays of numbers. We won't deal with arrays in this lecture. And they can even be other functions. For example, this function takes the square root of another function, which is the absolute value of negative 25. So there are a variety of different kinds of arguments. On page 143 we have a list of some logical functions: if, and, or, XOR, and not. Let's start with the if function. So the if function returns a different result depending on the values in other cells. The syntax would be equals if, open a bracket, logical test, comma, value if true, comma, value if false, close bracket. So we could state it this way: equals if, perform a logical test. If it passes the test, then what? Comma, if it fails the test, then what? Otherwise. For example, equals if I get hired, then I buy a car, otherwise I buy a bicycle. Or equals if I get a pay raise, then what? I can propose, otherwise I wait. Or for example, equals if my grade is greater than or equal to 50%, then I pass, otherwise I fail. So the first two terms of the argument are required, and the third is optional. And I know that because if it's in square braces, it may not be required. If it's not in braces, it is required. Let's apply this in a simple example. We'll go to our spreadsheet, and in cell A2 we'll enter pH, let's say it's 6.9, and we'll assign the name for that cell to be pH. And then we'll write a formula in cell B2 that evaluates the value of pH in cell A2 and decides whether it's acidic or basic. We're going to say that if the value of pH in cell A2 is less than 7, we'll say then it's acidic, but otherwise we'll call it basic. We'll start with that and we'll build from there. So in cell A2 we'll type in a value. Let's try a pH of 6.9. Let's give cell A2 the name pH. It'll make it easier when we write our functions. Recall how to do that? On the Formulas tab, click on Define Name. Excel is suggesting pH as the name for our cell, and that's what we want. We'll relegate the name of our cell to the functions worksheet. Notice that is the correct location, cell A2, and say OK. Now we'll write our function in cell B2. And this is what we'll type. We'll say equals if, hit tab to select, pH, notice how our name is found, hit tab to accept, is less than 7, that's our criterion, that's our test, comma, then, now when I put something in quotations, acidic, I'm telling Excel to print exactly what I have in quotations. That's the result if the test is passed. If the pH is less than 7, it prints the word acidic. Comma is otherwise. Notice here, value if false. If it's false, we'll write basic in quotations. We need to close the parenthesis that we opened. So there's our function. Let's hit enter and see how that works. It says it's acidic. It is dynamic, so if I change the value of pH in cell A2 to say pH 8, it should say basic. Well, that's a good start, but it's kind of primitive. What about if it's pH 7? We don't have a criterion for that. So we're back on page 143. Several if statements can be combined into a single function. That's called a nested if function, and we do this so that we can test several criteria simultaneously. Let's go back to our worksheet and apply this. So in cell C2, we'll nest together two if statements. We'll say if the pH is less than or equal to 6.9, then it'll be designated acidic. Otherwise, we can put another if statement here to consider more than one possibility. Otherwise, if the pH is greater than or equal to 7.1, then we'll tell it that it's basic. Otherwise, what's left over? well then it's neutral. We'll have to close two parentheses. So in cell C2, we'll say equals if tab pH, except that with a tab, is less than or equal to 6.9, comma, that's our test. Then what? Well, if it is, we'll say it's acidic. End of quote. Comma, otherwise what? Well, let's put another test in. If tab pH tab is greater than or equal to 7.1, then we'll describe it as being basic. Otherwise, it's neutral. We'll have to close our second brackets. And notice we opened two brackets, one here, one here. We'll have to close two brackets. They're also color-coded to guide us here, right? Black, then red, red and black. That should work. Press enter. So it says it's basic when the pH is 8. Let's try a pH of 6. That works. Let's try a pH of 7. And it's neutral. So we've refined our function to give us more options. We're back on page 143 for just a moment. These are the comparison operators that we began to use. Some of these are pretty obvious. Equals, not equal to is written as less than, greater than, less than, greater than or equal to, less than or equal to. Page 144. These are the logical operators, and, or, XOR, and not. At least those are the main ones. There's a couple others. Let's just briefly explain what these operators mean. The AND operator returns true if all of the arguments evaluate to true. So for example, equals AND A1 is greater than 0, B1 is greater than 0, and that would return true if the values in cell A1 and B1 are both greater than 0. But if the value in either A1 or B1 or both was not greater than 0, it would return false. That one's probably pretty obvious. We actually have two types of OR operators. We have the inclusive OR and the exclusive OR. Here's an example. Equals OR A1 greater than 0 or B1 greater than 0 returns true if either A1 or B1 is greater than 0, or even if both are greater than 0. So if the value in cell A1 is 5 and B1 is 0, it returns true. If the value in B1 is 5, but the value in A1 is 0, that still returns true. But if the value in both A1 and B1 is 5 in both cases, it's still true. So it's either or both is the OR situation. Compare the XOR, the exclusive OR. This returns true if the value in cell A1 or B1 is greater than 0, either. But if both the values in cell A1 and B1 were greater than 0, it would return false. So just to compare, let's say in the OR function, neighbor A has a dog and neighbor B has a dog. There's dogs in the neighborhood. If neighbor A and neighbor B both have dogs, there's still dogs in the neighborhood. It's true in all cases. But here, in the XOR, neighbor A has a dog or neighbor B has a dog. But if both have a dog, that's too many dogs in the neighborhood. That would return false if they both have dogs, one or the other. The last one here is the NOT operator. It's kind of a reverse logic. Equals not A1 greater than 0. What you're saying here, and essentially, think of it as a statement. We're saying that cell A1 is not greater than 0. Now, if the value in cell A1 was 0, then that would be true. It's not greater than 0. But if the value in cell A1 was, say, 5, then saying it's not greater than 0 would be false. So this returns false if the value in cell A1 is greater than 0. Otherwise, true. In this next example, we'll write a function that determines whether a student passes or fails. So here's a course that has both a lecture component and a lab component. And in some courses, it doesn't matter if you pass both portions as long as the average is greater than 50%. But in some courses, it does matter, like organic chemistry. And so you have to actually pass both the lecture and the lab to pass the course. So in this example, the student got 48% in the lecture, 75% in the lab. Is that a pass? Well, no, it's not, because they failed the lecture. We're going to calculate the weighted average. Lecture is worth 70%. The lab is worth 30%, so you combine those two together to get the weighted average for the course. But then we need to write a function to determine whether that's a pass or fail. Let's take a look at that. So in cell A8, I'll put a lecture average of 48%. And in cell B8, I'll put a lab average of 75%. And we want the course average. Now, before I continue here, I would like to display a certain number of decimal points. Let's say I want 1 decimal point. On the Home tab, there's this increase number of decimals and decrease. You can do that always. But perhaps a better way is to select the cells where we want to specify the number of decimal points and choose this numbers format icon. We'll select number as the type of number, and the number of decimal places I want is just 1. Say OK. Next, we need to name the cells for lecture average and lab average, and we'll use them in our formula for calculation. So I'm going to select cell A8. On the Formulas tab, choose Define Names. Lecture average is the right name. Relegate it to the functions worksheet and say OK. The lab average, define a name. Relegate it to the functions worksheet, say OK. We can now write the weighted average calculation in cell C8 equals bracket lecture. There's the function. Hit tab to accept. That's lecture average times 0.7, close bracket, plus, open a new bracket, lab. There it is. That's our function. Hit tab. Lecture average, lab average times 0.3, close bracket, equals 56.1. So there's our weighted average. Is that a pass or a fail? And this is the function we want to type in. Equals if tab and. So both have to be true. Tab. What has to be true? The lecture average, I'll accept that, tab, is greater than or equal to 50, comma, and the lab, there's tab, the lab average is also greater than or equal to 50, close bracket. So that's our test. Both have to be true. Then what happens? If both are true, the result is we'll write the word pass, comma, otherwise we'll write the word fail. Notice that I've opened 2 sets of brackets, black and red, and then closed 2 sets. Hit enter, and unfortunately, as we know, the student fails in this case. So nested functions are very useful. So for a last example, hazard classification. An acid or base is classified as corrosive if its pH is less than or equal to 2 or greater than or equal to 10. Otherwise, it's not regulated. So we already have a value for pH in cell A2, and we have the name pH stored. We'll work in cell D2 and write a function that reads the pH and determines if the chemical should be classed as corrosive if the pH falls outside the range of 2 to 10, or not regulated if it falls within the range of 2 to 10. Let's do that next. So here's the function we want to type into cell D2. We need an if or nested function. Equals if tab or tab pH tab is less than or equal to 2, or, that'd be a comma, pH tab is greater than or equal to 10, close bracket. That's what's to be tested. Then, if it is true that it's less than or equal to 2 or greater than or equal to 10, I'm going to say it's corrosive. Otherwise, it is not regulated. We open two sets of brackets and we close two. In this case, it's not regulated. However, if I said the pH was 1, it says it's corrosive. If I say the pH is 11, it's also corrosive. But if I say it's 8, it's not regulated. It is basic, but it's not regulated. So there's a few examples for writing some simple functions involving logical operators in Excel. On page 145 is an exercise for you to calculate your cumulative, that is your career GPA. So in order to graduate from the college, a student must pass all required courses in the program and attain a cumulative GPA or grade point average of greater than or equal to 2.000, and registrar's office will hold you right to the decimal point. So in Excel, I have this spreadsheet for you to work on. In column A, we have the semester. Column B are the courses. Column C are the number of credits that each course is worth. Column D is the letter grade that a fictitious student got. And column E is the numeric value that that particular letter grade is worth. So every letter grade corresponds to a particular numeric value. And A is worth 4 credits, B is worth 3, C is worth 2, D is worth 1, F is worth 0. So we multiply the numeric value of the letter grade times the number of credits the course is worth, and obtain the number of credit hours that the student earns for that course in that semester. That's then done for all the courses in the semester. The total number of credit hours is added, and then divided by the total number of credits possible in the semester, and that ratio gives you the term GPA. So we'll use some formulas here, multiplication and division, and we'll use a couple of simple functions to get this. Let's go to our spreadsheet. There's still a new function I need to show you. This file is on Blackboard. It's entitled Excel Worksheets, and you'll be looking at the GPA worksheet. So in column C, we have the number of credits each course is worth, and in column D, we have the letter grade that a fictitious student obtained in this. We want to then look up the letter grade in this table and find the corresponding numeric value. For example, for a letter of C, that's worth 2 credit hours. But rather than doing this manually and filling it in, there's an Excel function that does that. It's called a V-lookup function. So select cell E3 and type equals VL. There's the function. It's called vertical lookup. We'll be looking up the value of D, the letter grade, in this table. So it's called a vertical lookup function. Now, if the table was arranged horizontally, it would be called an H lookup, horizontal lookup. But because our table is vertically arranged, we'll use a V-lookup function. Hit Tab to accept it. What do we want to look up? We want to look up the letter grade that's in cell D3. Now, it turns out that that's hiding. We can't select it by clicking it, but we can type it in. Just type in D3. You don't have to put caps in there. Excel doesn't differentiate. Comma. Now, where are we going to look this up? We're going to look it up in this table, so select the address of the table. This table is in cell I3 through J7. Now, one of the stipulations is that the value you're looking up that's currently in cell D3 has to be in the first column, the leftmost column of the whatever you select. So the table could be 5 columns wide. It doesn't mean that the letter grade has to be in the leftmost column of the table. It just means it has to be in the leftmost column of whatever you select in your array. So make sure this is the leftmost part of your selection. So it's going to look up this value, D3, in the leftmost column of your selection in this table's address. And it needs absolute reference, but I'll leave it to show you in a minute. Comma. Now, where is it going to find the corresponding value? Well, assuming that this is the first column in the table, wherever you select, then count which column it's in. It's in the second column, so give it the column address, column 2, and close the bracket. So that's it. So we tell it to look up the value that's in D3, and where will it look for that? In this table address. Make sure that what you're looking for is in the leftmost column of what you select. And which column is it in? In our case, it's in the second column. And hit enter. And you see it correctly said that the letter grade corresponding to a C is 2. So you could simply drag that formula all the way down. But I want to show you that there's a problem here. What did I miss? Well, we should have had an absolute reference to our lookup table. I3 to J7, hit F4. Because when we drag, we don't want this formula for the table to change, otherwise it'll be looking down here for it and it's not there. But we do want a relative reference to our letter grade so that that will move down the row as we drag. So if I hit enter and now drag this formula down, so that did calculate correctly, right? A B is a 3, D is a 1, and so on. It worked. You can drag this formula all the way down to the end of the page and then delete the cells you don't need. Next, we want to determine how many credit hours this grade is worth. So we're going to use a formula that'll be equal to the numeric grade value, E3, times the number of credits the course is worth, C3, and hit equals. So that is worth 6 credit hours. Now we have a relative reference, and that's what we want. So when we drag this formula down, it'll increment the formulas accordingly. So there's E4, C4, E5, C5, and so on. To get our term GPA, we're going to divide the total number of credit hours by the total number of credits. So we'll use the sum function. Now I could do it this way, equals SUM, open a bracket, and drag to select the cells that I want to sum up, and close the bracket and say equals, and that'll work fine, 47. But there is another option just to show you. On the Formulas tab, there's this Auto Sum group, and if we choose in here, these are some common functions, sum. Excel will automatically guess that every number sitting above the cell is what you want to sum up, and if that's correct, just hit enter. So it gives you the same result. Likewise here, I can choose Auto Sum, sum C3 to C8 is correct, and say enter. So the term GPA will be equal to the total credit hours divided by the total credits. I'll write a formula for that, equals 47, that's F9, divided by 20, which is C9, equals. There's my term GPA. So continue the process for all 6 terms. Let me go back to the notes to show you how to finish this. Once you have all 6 terms calculated in the same fashion, you'll want to get the cumulative GPA for your career. To do that, you need the sum of all of your term credit hours for each 6 semesters. In this example, that's 290 credit hours, divided by the sum of all of your term credits that are possible. In this case, the total possible credits are 120. So 290 divided by 120 will give you your cumulative GPA. 2.417 in this example. On page 147 and 148 in your notes, you'll find a procedure for creating a molar mass calculator in Excel. On Blackboard, you'll find a workbook called Molar Mass Students. So in columns I, we have the symbols of all 118 elements. Not that you'd ever use them all. And in column J, we have the atomic masses of the elements as well. These were taken from Wikipedia. In column K, we have the names, and L, more information, but we'll be using columns I and J exclusively. If you want to know more about the other information, you could read your notes, page 147, 148. So start by writing the formula of the compound whose molar mass you want to calculate, without regard to subscripting. In column B, write down the symbols of the atoms that are in the compound. So I have calcium and hydrogen and carbon and oxygen. In column C, write down the number of atoms of each kind in the formula. So we see we have 1 calcium, we will have 2 hydrogens, and 2 carbons, and 6 oxygens. We want to enter the atomic masses that corresponds to each of these elements in column B. So rather than us manually finding them, we're going to have Excel do it using a lookup function. So in cell D2, we'll start the formula equals VL. There it is, that's our lookup function, tab to accept it. Now what value do we want it to look up? We want it to look up the value in cell B2, which is calcium, and comma. Now it's asking us for the table array that it's going to look in. We need to give it the address of the cells I've highlighted in green. So how are we going to do that? You could select and drag all the way down. That's pretty tedious. Another way is you could just select the top 2 cells, I1, J1, then use the scroll bar at the right, go down to the end of the group, and then hold down the Shift key before you select the last 2 in the group. Notice our array is from I1 to J119. I want to show you a third option. We could select the first 2 entries, I1, J1, then hold down the Control key and the Shift key, and then hit the down arrow. It selects everything down to the end of this last cell before there's a vacant cell. And there we have the group selected. Now we want an absolute reference to the table values, so that's not going to change. So make sure you hit F4. Comma. It's looking up the value for our element calcium in this table array, and it's going to have to return to us the value that's in which column. Well, recall that the lookup value has to be in the leftmost column, and relative to that, the returned value is in the second column, second from the left, so that's 2. We need one more part for the array. We need to select exact match. Once I put the comma in, it's asking me, do I want an approximate or exact match? I need exact match. So double click on false or exact match and close the bracket. That should work. Hit enter. Is that the correct atomic mass of calcium? Yes, it is. And because we have relative referencing to our lookup value, it should autofill correctly. I'm going to go past what we need in the event that at a later time I'll have more elements in my compound, so the formula will already be there for me. Okay, so we need the total mass of each element present. That'll be equal to the atomic mass of one element times the number of those elements in the compound. That's D2 times C2. Well, it's just 1 for calcium, but let's scroll that down. And again, you could go farther in the event that you have more elements in another compound. And finally, it's just a matter of summing up the masses of each element. So that'll be equal to the sum of, just select the cells that have values and enter. So there's our molar mass of calcium bicarbonate. Now there's another way that we can do the same thing. It takes a little longer to set it up, but then it's much easier to use when you go to use it. So the first thing we have to do is assign a name to every atomic weight. So the name for this atomic weight would be H. The name for the atomic weight of helium would be He. The name for the atomic weight of lithium would be Li, and so on. And we do that using the name manager, and it's easier than you might think. So let's start by selecting cell J2, which is the atomic weight of hydrogen. Now I'm going to assign the name H to it, so click on Define Name. And notice that Excel has automatically suggested H, which is great. It's immediately adjacent to our atomic mass, so it makes life easy for us. We don't have to type it in. Furthermore, you don't have to restrict the scope of this to the particular worksheet because we only have one worksheet. So it makes it really easy to do this. Just say OK. Do the same for helium. Define name, and it says helium, and we got it. Good. And click on the atomic weight of lithium, define name, and accept it. And you can go all the way down the list. Now, I won't do that all with you now, but I'll do the elements that we need for this calculation. We'll need hydrogen, which we have, carbon, oxygen, and calcium. So I'm going to go down to the bottom and choose calcium, element number 20. Here it is. I'll choose define name. Calcium is good. And we need oxygen, which is here, 15.999. Define name, and oxygen is good. And the last one here is carbon. So click on the atomic weight of 12.011. Click define name. Now, notice that Excel has suggested C underscore because C is not one of the names that's allowed as a cell name. So you could accept C underscore, but I think it's easier to put something like C dot because underscore requires 2 keystrokes. So I'm just going to replace the underscore with a dot, and that's an acceptable name, and say OK. Once you have all your names assigned to your atomic weights, it's very easy to write a formula for this. I'll do it right here in cell B14. Equals the sum, S-U-M, tab. Now you could add them using the add operator, but it's easier just to list them, separating each value by a comma. So I'll type in CA. I didn't even bother typing capital C because Excel recognized it, except that with a tab. Comma, H. Say yes, tab, and that'll be times 2. Comma, I'll need carbons times 2, that'll be C dot. I'll accept that, times 2. Comma, and finally I need oxygen, that's O, accept that, times 6. Close the bracket and enter, and there's the molar mass, 162.11, the same as we had previously determined. That's quite an easy method to use, very handy. Enjoy it.